Okay, let's look at the powers and roots of complex numbers. Alright, so once again, we're going to use the Euler's formula or exponential form. If you look at e to the, say, I theta, alright, so if you raise it to the nth power, right, then you can see that this is going to be e to the I n theta, right? Because of one of the exponential property. Alright, so this means that we can write it in sine and cosine. So e to the I theta is identical to cosine of theta plus I sine of theta, and we're going to raise it to the nth power. Alright, especially when n is a big number, then this computation might not be fun, but it's fairly easy because here, this is exactly the same thing as the left hand side. Right hand side is going to be, using Euler's formula again, cosine of n theta plus I sine of n theta. Right? So raising to the n is actually corresponding to multiplying the angle by n. Right? So once you've done that, let's look at this example. Right? So here's an example. Right? Remember that we have a double angle formula. So I'm going to write down, so double angle formula. Alright, so it goes something like this. It's sine of 2x, or 2 theta, is equal to 2 sine of theta times cosine of theta, and a cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. Alright, we can use complex numbers to come up with these double angle formulas. Right, actually maybe formulas. Alright, so let's do that. Alright, so here's how it goes. We know that cosine of, say, 2 theta plus I sine of 2 theta. Right? We can also write it as, okay, so we're doubling the angle, which is the same thing as squaring it. So this is the same thing as a cosine of theta plus I sine of theta squared. Right? Then if you multiply this out, you're going to get this. So if you multiply it out, so you're going to have a cosine squared of theta plus 2I cosine of theta, or maybe, let's see. Yeah, maybe I'm going to 2 sine of theta cosine of theta, and the I square would be negative. Then you have a sine squared of theta. So all I did was just multiply it all out, right? Then if you collect the real part, so here, and we get this. Cosine squared of theta minus sine squared of theta. So that's the real part. Then plus I. Then you have a 2 sine times 2 sine of theta cosine of theta. So that will be the imaginary part. So look at the beginning. If you compare, cosine of 2 theta is the real part, and the right hand side real part is this guy. So we have cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. So we verify this formula there. And if you compare the imaginary part, which is sine of 2 theta on the left, and on the right you have 2 sine of theta cosine theta, which verifies the first double angle formula. Alright, so using the same technique, you're going to have a homework. It's going to be, we're going to find the triple angle formulas. So triple, so this is going to be your homework. Triple angle formulas. Right, so we're going to have to find out. So you're going to have to find the formula for sine of 3 theta, and you need to find what it is, and then cosine of 3 theta is going to be what? Right, so that's your homework, right? And I think you know exactly what to do. You just basically change it 2 to 3. All right, so if you have a power, so you have z to the n, right? So if you write it in exponential form, it's easy to see. R e to the I theta, then raise it to the n, which is going to be simply, right, we're going to have to raise r to the n, right? Then you have a e to the I n theta, right? Which is the same thing as r to the n. So the magnitude or the absolute value is raised to the nth power. And then if you look at the angle is multiplied by n. So I cosine of n theta, right? Maybe I should use the bracket or something like that here, right? So that's the power works. And if you raise z to the, actually the 1 over n, or nth root, how about the nth root of z? This is going to be same thing, r e to the I theta, raise it to the 1 over nth power, right? So this is going to be e to the, so it's going to be an nth root of r. Then you have a e to the I theta over n. Right? So if you want, you can write it as nth root of r. So the absolute value is raised to the 1 over n power, or nth root. And then you are going to have cosine of theta over n. And then let's see, I messed it up, sorry. This was supposed to be sine, hopefully I said that right, and the sine of theta over n. Right, so that's how the root, nth root of a complex number works. All right, that's it. I hope that this was clear.